Hello calculus students, it is time for Unit 1 review. In this video, I'm going to go through the solutions to the review problems given out in class. Because it takes a while to write when you're doing this on the screen. A lot of it's been written already, so you may have to pause and take a look at the information that's written and then move on. Here we go. So the first part of the review was the non-calculator portion, so you should make sure that you can do these kind of by hand. When we take the test, we'll put our calculators away during this part of the test. All right, the first question is to find the greatest common factor, the GCF, of the expressions below. The hardest part are the numbers. So we need to find the greatest common factor of 20 and 32. You might be able to think about it and realize it's 4. 4 is the largest factor that they both have. But if you're not sure, remember that you can make factor trees and find the prime factorization. 20 is equal to 2 times 2 times 5. 32 is the product of 5 2's. So we see that they have a pair of 2's in common. So the GCF of 20 and 32 is 2 times 2, which is 4. And now we have to go back and do the variable part. The first expression has 2 factors of x. The second one has 3 factors. So they both have at least 2. So they have 2 factors in common. So this would be 4x squared. Then look at the y's. We do one variable at a time. This expression has 1 factor of y. This one has 4. So they have 1 factor in y of y in common. So the GCF is 4x squared y. Right, the second one's a factoring method. We worked on a factor by grouping method. Remember, you got to find AC. A times C is negative 12. And B is 4, so you can find two numbers whose sum is 4 and product is negative 12 and split up the middle term. But this one we can kind of do by guess and checking. I would recommend trying to figure it out before using that method. If you get stuck, that method will always work. So the first clue is that the first term is x squared. So I know I need an x and an x here. So x times x is x squared. I also have a negative 12, so I know whatever numbers I put here and here have to multiply to negative 12. Well, I started thinking, what if it was negative 2 and positive 6, or 2 and negative 6? Do those work? Well, whatever numbers I put here, they have to add up to 4. So I see that it must be the first choice, minus 2 plus 6. So I just kind of started looking for clues. What multiplies to x squared, then what multiplies to negative 12, I gotta make sure everything else works. So if we multiply this out, we get x times x is x squared, x times 6 is 6x, negative 2 times x is minus 2x, and negative 2 times 6 is minus 12, and we see that this gives me what we wanted, 4x minus 12. So this is the right factorization. So that's kind of trial and error. I just tried negative 2 and 6 and it worked out. If it didn't work out, I'd try a different pair of numbers that multiplied to negative 12. So that's kind of the guess and check method. All right, that works for easy ones. If it's tough, use the method we learned in class. Okay, now this question 3 says find the x and y intercepts for the equation below. So I kind of have this solved already. To find the x-intercept, that's points on the graph where y equals 0. So we set y equal to 0 in the equation, and that's where that came from. 0 equals 3x minus 18, so that's easy to solve. We get x equals 6, and that's the x-intercept. All right, to find the y-intercept, we set x equal to 0. So I did that here. I put 0 into the equation for x, and we get y equals negative 18, so that's the y-intercept. Okay, it's a line. It can only cross at most once the x and y axis. All right, now, next question is about symmetry. It's about symmetry about the origin. There were 3 kinds of symmetry we looked at. Symmetry about the x-axis, the y-axis, and about the origin. To show that this is symmetric about the origin, we really want to show that if any point xy works in the equation, then so does the point minus x minus y, which is actually its rotation about the origin. So The way we show that is that we replace x with minus x and y with minus y in the equation and see if we end up with the same thing. So that's what I have here. I have minus y squared equals minus x squared plus 6. But minus y squared is equal to y squared. Minus x squared is equal to just x squared. And I see that the equation simplifies to the same thing I started with. Therefore, if xy works, minus x minus y works, and we have symmetry about the origin. Here we go. Number 5 says, solve the following system of equations. All right, now there's a variety of ways to solve this. These are equations for lines, but I'm going to use the substitution method. So I solved the first equation for y, and I got y equals 3 minus x. I just subtracted x from both sides. Now we take that and we substitute in for y into the second equation. And this is what we came up with here. So this right here used to be y, and I put our new expression in for it. Then you just solve like algebra 1, and you get x equals negative 4. And if I want to know what y is, I go back to this original equation here that I used for substitution, and I just put negative 4 in for x. Y equals 3 minus the negative 4, which equals 7, which means the solution is the point negative 4 comma 7. All right, this one's quick. Find an equation for the line that passes through 2, negative 1, and has slope 5/2. I use good old point slope form. All right, so all I did is put in the coordinates of the point we know in for x1 and y1. I substituted 5/2 for m and simplified, and that's what I got. All right, let's go forward. Now we're ready for this. It says, find the equation of a line that passes through 6, 1 and is perpendicular to y equals 3x minus 7. Well, if it's perpendicular to this line, it must have the opposite reciprocal slope. That would be negative 1/3. Okay, so I use point slope form. I just put in 6, 1 for x1 and y1, and negative 1/3 for the slope. That's what you get. Okay, 8, functions. So our function is 1 over the quantity x squared plus x. So it says find f of 4. No problem. We all got this. I just put 4 in and I get 1 over 20. The little bit trickier one, or maybe a little bit newer, is f of x minus 2. We want a simplified expression for what this is. So wherever I had x in the formula for f of x, I put x minus 2. So that's why I have parentheses x minus 2's there. It'd be x minus 2 quantity squared plus x minus 2, following that pattern. The input squared plus the input. Now, if you multiply this out, x minus 2 squared is equal to this. And I just substituted it into the denominator. So I just plugged it in where x minus 2 quantity squared was. We still have the plus x minus 2 from there. If you simplify, you get this little beastie. All right, the last two in the non-calculator portion. This one is a composition of functions. We're substituting 3 into the function g, and then whatever we get, we substitute that into f. So the first step is put 3 into g, and I got negative 5. So we put negative 5 into f. This quantity right here, g of 3, is negative 5. So there it is. And now when I put that into f, I get this, which is equal to the square root of 4, which is 2. All right, now evaluating a piecewise function. So this has 2 pieces, 2 different parts. It could have 3, it could have 4, it could have any number. So we just got to decide which piece we're supposed to use. So to find h of negative 4, I got to figure out which piece that belongs to. Well, the first one is x is less than or equal to negative 2. Negative 4 satisfies that. So I'm going to use that rule. Negative 4 squared plus 1 is 17. All right, on this one, we're substituting negative 2. Negative 2 is less than or equal to negative 2 because it's equal to negative 2. So we're still using the top rule, and we get 5. Finally, to find h of 0, 0 is greater than negative 2. We finally get to use the second piece here, and 4 minus 0 is 4. All right, wow. Phew, that was quick. Alright, now time to break out the TI-89. This part might take a slightly longer because I'm going to enter the commands into the calculator. Okay, it's time for the calculator portion. So let me break out my TI-89. Remember, I have an older version here, but the commands are the same as yours. So the first one is to factor that expression. So first, make sure we're in the home screen. Then press F2. That's kind of the algebra tool menu. And we want the second one, factor. So we just have to enter this right here into the calculator. Sorry, it's kind of weird. My calculator, my program can't do a pen and a calculator at the same time. So here we go, 2, and then we have x to the third. So that's 2x to the third plus 3x squared. Then we have minus 2x, and then minus 3. Hopefully I entered everything okay, and hit enter. There it is. That's what I wrote down. Quantity x minus 1 times quantity x plus 1 times the quantity 2x plus 3. Alright, score 1 for the 89. Here it says solve, provide exact solutions. Okay, so I don't want decimals for this. I want square roots in my answer, and the calculator will give us that. So same place, press F2. But this time, the first one, solve. So we just enter the equation, x squared minus 4 times x plus 1. Then the equals is right here under the x key, so equals 0. Now, this is important. I have to put comma x. I have to put comma and then the variable I'm solving for and close the parentheses. So when we use the factoring command, we didn't have to do that, but for solve we do. And if I press enter, there we go. We have, if I distribute the negative, minus square root of 3 plus 2, I wrote it there, and square root of 3 plus 2, I wrote it there. Okay, what's next? Okay, on this one. All right, so we're still in the calculator section. Let me press clear here. It says solve this. Well, we can't do it just the same way I did the last one. All right, so we're going to use the solve command. So I'm going to press F2 and then 1, solve. Now I have to be careful. I need another parentheses here. So parentheses x plus 2, close the parentheses, then square root, and we have 9 minus 2x. I have to close the parentheses for the square root, then equals 0, so equals 0, and then I need a comma and an x to tell it what to solve for, and close the parentheses. Voila, 9 halves and negative 2. Okay, this next one says find the x and y intercepts of the equation below. Alright, I'm not going to spend a lot of time on this. To find the y-intercept, you just substitute x equals 0, and actually you see all that's left is minus 76. To find the x-intercept, you set y equal to 0 here, and you have an equation to solve. So we have a nice little quadratic equation here, but you just enter it in your calculator the same way we did the last two equations. Your calculator tells you that these are the two x coordinates. So these are the points where the graph crosses the x-axis. All right, I'm going to leave it at that. All right, we're getting there. So for number 5, we made tables like this. This was an important tool to help us when we're factoring something by hand, or at least with a scientific calculator. It says find two numbers whose sum is 11 and whose product is negative 102. So remember, the idea of the table is we're checking pairs of numbers that always add up to 11, and we're searching through them for the right pair whose product is minus 102. So you start by dividing the sum by 2. 11 by 2 is 5.5. So I rounded the first one down to 5, and the second one up to 6. 5 plus 6 is 11, and that's where I start. 5 times 6 is 30. Then I made the 5 go down by 1, and the 6 go up by 1. 4 and 7 still add up to 11, and the product's 28. Now, I'm a long way from minus 102, so I started skipping some. I skipped 4. So I subtracted 4 here, and I added 4 there. Those two still add up to 11, their product's 0. I'm still far away. So I subtracted 4 again. I got negative 4, added 4, I got 15. Product's negative 60. So getting closer, so I start going by 1 again. 1 down, 1 up. The product's negative 80. And if you go to the very next one, you get the winning pair. Negative 6 plus 17 is 11. Negative 6 times 17 is negative 102. So that's a powerful tool I want you to remember. Okay, now we're getting close to the end. There are 2 questions left. This says find all the solutions to the systems of equations below. This first one's nonlinear. It's the equation of a parabola. So this is going to be a little bit harder, but we have our 84. So we start by substituting this 2x minus 6 in for y in the other equation like I've drawn there. And you get this. 2x minus 6 is now there where the y was. So we got 2x minus 6 equals x squared minus 8x plus 16. Alright, now you can just enter that equation the way it is in your TI-89. So I don't want to go through that again. But this time it's not equals 0. You just enter 2x minus 6 equals x squared minus 8x plus 16. Put comma x, because that's what we're solving for. And it'll solve it for you. So you get x equals to square root of 3 plus 5. This mess right here, all I did is went back and figured out the y value. So y equals 2x minus 6, so I just did 2 times the ugly x value we found, and I end up with, that's the y coordinate. Alright, so I didn't write out the ordered pair, but there's x, there's y. Then the other possibility for x is it's minus square root of 3 plus 5. That's the other one your calculator gives you. And I did the same thing. So I took that and I figured out what the matching y coordinate was, and I got that. Alright, time for the last one. And I'm going to bring back my 84. This is something a little bit different. Alright, so clear that mess out. We want to come up with a graph for an equation. Now it says an accurate graph. That means I want you to plot some points on the graph and then sketch the curve that goes through them. So to do that, let's use our calculator. So press the diamond key and the y equals. And you see I already have it there. It's 2 raised to the exponent x and then minus 4. So if you're not sure how to enter that, I'll go ahead and re-enter that. So clear. So 2, use the exponent key, and then x is an exponential function minus 4. And hit enter. Now, we can get a peek at what the graph looks like by hitting zoom 6. And it's a typical exponential graph. It has a horizontal asymptote and it starts curving rapidly up like that. And if I want to make it match the graph I have here, then I just enter negative 5, positive 5 for x min and x max, negative 5 and 5 for y min and y max, and then if I press diamond graph, it kind of looks exactly like the one I have here. So if you want to match the paper, you can change the window settings. Now, to get the points, press diamond table. And your table, you should be able to scroll up and down to get the points. We see that it's very close to negative 4. It's negative 3.9 until we get to about negative 2. Alright, and then it starts kind of moving upwards. And then it increases rapidly. At 3 it's 4, at 4 it's already 12, at 5 it's already 28, it's off the graph. Okay, so go ahead, plot the points that you can, and sketch in the curve like that. Alrighty, this has been kind of a long video, covered a lot of information, and hope you do well on the test. So practice the problems, make sure you're good at the calculator commands, and good luck on the test.